Lewis' concept of acids and bases. In the previous 3 parts, we learned about the Brønsted-Lowry concept of acids and bases, which depends on the transition of the proton from the acid to the base. However, this concept did not explain how the proton bends to the base. As we know, a proton is a hydrogen ion, which is a hydrogen atom that has lost its electron. Also, they couldn't explain the acid-base behavior in some reactions which does not involve proton transfer between substances, as shown by the following equation. So, the concept of Lewis appeared, which is more comprehensive than that of Arrhenius and Brønsted-Lowry. But how was Lewis able to solve the shortcomings that appeared in the concept of Brønsted and Lowry? So let's see how together. The first shortcoming is that Brønsted-Lowry concept did not explain how the proton bends to the base. So Lewis studied these reactions and noticed that the base is a substance that donates one or more pairs of non-bonding electrons and donates them to the acid when it interacts with it. This indicates that the acids have empty orbitals to receive one or more pairs of electrons. For example, when ammonia reacts with the acid, we find that the nitrogen atom in the ammonia molecule has a pair of electrons that are not bound to any atom. As we know, nitrogen is in the 5th group of the periodic table, so it has 5 valence electrons and will bend to 3 hydrogen atoms to form the NH3 molecule. As we can see, one pair of electrons remains without bonding to any atom, while the hydrogen ion has an empty orbit. Therefore, the hydrogen ion accepts a pair of electrons from ammonia, and a coordinate covalent bond occurs between them. HCl is still considered an acid, and NH3 is still considered a base, so the rule has not changed. But Lewis explained how the proton bends to the base for acids that contain ionizable hydrogen. Therefore, HCl is considered an acid according to Lewis's concept because it's the acceptor of a pair of electrons, while NH3 is considered a base according to Lewis's concept because it's the donor of a pair of electrons. The second shortcoming of the Brønsted-Lowry concept is that they could not explain the acid or base behavior in some reactions that do not involve proton transfer between substances. For example, the concept of Brønsted and Lowry could not explain the acidic behavior of zinc ions in water. As we can see, the zinc ions do not contain a proton. But when Lewis studied these reactions, he noticed that the water molecule has a pair of non-bonding electrons, while the zinc ions, as we can see, has empty orbitals. So they will form a coordinate covalent bond. Therefore, the zinc ion is the acid because it's the acceptor of a pair of electrons, while the water molecule is the base because it's the donor of a pair of electrons. Lewis changed the concept of acid and base depending on his explanation of how acid and base are bonded. As we know, the process of bonding atoms to each other depends on electrons. Thus, Lewis defined the acid as a substance that can accept one or more pairs of non-bonding electrons from another substance because it contains empty orbitals, while the base is a substance that donates one or more pairs of non-bonding electrons for another substance. Thus, we will add Lewis's acids to the acids found by previous scientists. They are the positive ions of transition metals, and boron and beryllium compounds. While the bases remain the same, and Lewis did not come up with a new ones. Now let's solve together a set of examples on the concept of Lewis. In the first example here, it's required to determine the Lewis acid and base in the following reaction. In the first reaction, as we can see, the Fe+3 ion is one of the positive ions of transition metal, so it's Lewis's acid. Cn- ion will be the base. And it's also a Brønsted-Lowry base because it's a negative ion that does not contain hydrogen in its composition. Another example, as we can see, Cu+2 is a positive ion of transition metal, so it's the acid in this reaction. Therefore, H2O is the base in this reaction. Another example, as we can see, the ammonia molecule has a pair of non-bonding electrons, so it will donate it to boron, and a coordinate covalent bond will occur between them. BF3 is the acid because it's the acceptor of a pair of non-bonding electrons, whereas NH3 is the base because it's a donor of a pair of non-bonding electrons. At the end, let's compare the acid-base concepts of the scientists Arrhenius, Brønsted-Lowry, and Lewis. Arrhenius defined the acid as producing a hydrogen ion when dissolved in water, while the base produces a hydroxide ion when dissolved in water. Brønsted-Lowry identified the acid as a proton donor in its reactions, while the base is a proton acceptor in its reactions. Lewis defined the acid as the acceptor of a pair of non-bonding electrons, while the base is a donor of a pair of non-bonding electrons. Big thanks for watching at the end. Don't forget to like, share, and subscribe to receive my new videos.